Here we're gonna see an example or do an example of an application of a multiple linear regression model on a data set called the diabetes. The diabetes data set is actually from the Scikit-Learn library data set. This data has about 10 physiological variables or attributes for 442 patients, including their age, their sexes, body mass index, blood pressure, and 6 serum attributes. The data shows an indication of the patient's disease progress after 1 year. So this data is already on Scikit-Learn. We can use it. We don't have to download it or upload it from somewhere. But I have actually uploaded two IPython file. One is the template file and the other one is the complete version. So please download those files and open up the template file and try to follow along with me as I develop this project. I want to apply a multiple linear regression model for this data set for the independent variables that are these 10 attribute or physiological variables, and the target variable is going to be the response as you see in the table. Importing the libraries that we need. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, and also we need to import the scikit-learn dataset, so we can import the dataset diabetes that we need. So import from Scikit-Learn import datasets. So this is going to help us to import the diabetes datasets from these datasets. Let's load the data now. I'm gonna call my datasets diabetes, and then I'm going to use the load database function to load the data. So datasets load diabetes. So this is going to load the data, and then let's take a look at the feature names of this. I put it in the diabetes name, so diabetes feature names. So this is going to print out the features. So we have 10 attributes here: age, sex, BMI, body mass index, the blood pressure, and 6 serums. Next, we need to split the data into training and testing so we can train our algorithm. So let's do that. Let's split the data. First, we need to import the split function from Scikit-Learn model selection, import train test split. All right, and now we're gonna split the data. Xtrain, I'm gonna show it with capital X because we have multiple independent variables, multiple attributes. X test, Y train, Y test. This is equal to the train test splits. Then I'm going to give the data diabetes data. So this is going to give all the data, and then this is for the X variable. For the Y variable, I'm going to give it the target, diabetes target. So this is going to give it the target variable, and then I want to have it 20% use for test size and 80% for training. So test size equal to 20, and I'm gonna use the random state 0. So all of us will get the same output. Okay, now let's start building the model. So we need to import the model from the linear model module from a Scikit-Learn linear model, import linear regression. Okay, so we import the linear regression. Also, let's import the R score from Scikit-Learn metrics, import R2 score. All right. Let's create a linear regression model. I'm going to call it my model. And this is going to be a copy of linear regression. Linear regression. And we can also fit our model, my model, using the fit function, train our data. We could use the fit function here, but just for the sake of it, let's do it in another line. Fit, then I'm gonna fit in our training data set values, X train and Y train. Make sure to use the capital X. So what happens here is our model is now trained using the training data set, and what it means for linear regression is the values for coefficients are figured out now. So now we have all the coefficients. We have the equation. We can now make a prediction. So let's actually print out and take a look at the coefficients. All right, my model dot coefficient coef underscore. So this is going to print out the coefficients, which have 10 coefficients. These are the slopes for each attribute's independent variable. We can also print out the intercept here. So I'm gonna print that out. Print intercept equal to, and my model intercept underscore. So as you see here, I put underscore after the coefficient and intercept because everything that ends up with underscore, those are the model's values figured out. Those are like the outputs of the model, or it's not a user entered value. These are models computed values. So the intercept is 150 to almost 0.54. So now let's make a prediction. I'm gonna call it yPredict. I'm gonna ask my model to make a prediction on the test data set. Predict, and then I'm gonna give it the X test. So what happens here, it made the prediction and put it on the yPredict. We can now print out the R2 score or R square value for this prediction to see how accurate it is. Print R squared for testing dataset equal to, and then I'm going to call the R2 score, and I'm going to give it the actual value of y's and the prediction. So y test and y predict. So the R squared is about 33%. We can also actually print out, we can also print out, make a prediction for our training data set and print out the R-square value for that. This is okay for the linear regression model because it's already figured out the coefficients, so we can actually do that. So let's do it. I'm gonna call it the y-predict training. That's equal to my model make a prediction on the X train. So now it made the prediction and put it on by prediction value. Now we can figure it, we can print out the R square value. R squared for training data set equal to, and then I'm gonna give it the RS2 R2 score with the actual value, which is y train, and with the prediction y predict train. Okay. So for the training data set, our prediction is about 55%. 55%. All right, we have now the accuracy measures. All right, now that we made our prediction, let's plot our data. Okay. So let's name the labels for the x-axis and y-axis. PLT x label, I'm gonna call that y test, and for the y-axis label, I'm gonna call it my prediction, y predict. Okay, and I want to ask the pyplot, matplotlib pyplot, to show the data points using a little circles. You can specify how do you want to show your data values. Okay, so let's do that. Plot, plt plot, and then plot the y test versus y predict using little circles. Okay. All right, now let's specify what we want to be the size of the x-axis and y-axis. Okay, so let's do that. I'm gonna say x equal to numpy line space, and I'm going to have it between the 0 and 300. Let's specify 0 and 300. Okay, 0 and 300, and now I want to plot the x and x. This is going to draw actually a line, just a straight line. And now let's actually show the plot. So plt show. All right, you might get a different color here. So this is what we get. We plotted the y test versus the y prediction. And this is the regression. So if our regression line was perfect, our linear regression model was perfect. I shouldn't say linear regression line because we have multiple linear regression, and that would be actually not, it wouldn't be a line. It's multi-dimensional. We have like 10 independent variable here. So it's not a line. All right, so if you had a perfect prediction, all these data points would have fallen on this line here, which is y test versus y predict. So this shows that, as we saw using the R2 score value or score value in 33%, our our model is not perfect.